So welcome everyone to BALPA's webinar on the topic of GPS, GNSS, jamming and spoofing. I'm delighted to welcome you to the webinar. It's hosted by the British Airline Pilots Association and it's in conjunction with Boeing and Airbus. My name is Stuart Clarke, BALPA Flight Safety Advisor, retired Airbus A320 series A380 captain. It's my pleasure to host the event. I'm going to be ably assisted by Captain Mike Thrower, who's the chair of BALPA's Air Traffic Management and Aerodromes Committee, and he's going to be collating the questions and comments for the Q&A session at the end of the webinar. I'd also like to thank Ian Richmond, BALPA's Digital Marketing and Comms Officer, who's organised the technical arrangements. Now, a significant amount of BALPA's activity centres on flight safety and technical. This particular issue overlaps the activity of a number of different technical committees, in particular air traffic management and aerodromes, also accident analysis and prevention, security, training, licensing and ops. Also our emerging technology committee, which oversees BALPA's remotely piloted aircraft systems and urban air mobility activity. I'd also like to mention our close working relationship with GATCO, the Guild of Air Traffic Control Officers. We hold joint meetings across various areas of activity with them. We run webinars jointly, such as this one, and we support each other's technical activity. Now, when I did my own pilot license exams over 30 years ago, the exam syllabus at the time still included Decca and Loran navigation. Some of the captains I first flew with when I was a new co-pilot had actually flown aeroplanes that still use celestial navigation. And the first large aircraft I flew was an original 100 series A320, which used mix IRS with DME updating. So no TCAS, no EGPWS, SATCOM, CPDLC. Since then, as you know, GNSS has revolutionized aviation navigation. The reliability of GPS technology is critical to the safety and efficiency of aviation operations. However, the rise in incidents of jamming and spoofing presents significant challenges and threats to the industry. Today's webinar aims to delve into the issues, explore the nature of the threats and the strategies we can employ to mitigate them. We're also pleased to highlight the important work being done by Ops Group. They've got an ongoing work stream on GPS spoofing, which has recently commenced and is open to all industry participants. And just a note to say that if there's anyone from Ops Group online, please feel free to use the chat function to share information about your ongoing work group on this subject as well. So today we're really privileged to have esteemed experts from Airbus and from Boeing. Ian Goodwin is Director of Flight Safety, Safety Enhancement and Chair of the Airbus Product Safety Committee. He's joined by Laura Martin-Sacristan, the Flight Ops Engineer. Dr. Kirk Vining is Senior Technical Fellow for Flight Ops and Chief Pilot for Product Development at Boeing Commercial Airplanes. Kirk's joined by Nancy Ho, Flight Ops Generalist. We're extremely grateful for Ian and Kirk, Laura and Nancy giving us their time to provide insights into this thorny question. Throughout the webinar, we encourage you to engage actively. Please use the Q&A function rather than the chat box to submit your questions and comments, which Mike will be monitoring and will try to collate and address as many of those issues as possible during the Q&A session after the presentation. So without further ado, I'll hand over to Kirk and Nancy, Ian, Laura for their presentations.
Thank you, Stuart, and thank you everyone that's attending, and appreciate your interest in the topic. My first encounter with GPS jamming was 2016, flying a 777 into Manila, and the ILS was out, so we had to go around the back way to hit that VOR approach to get below that. It was a rather high overcast, but to get below that. And so we had lined up and geared down in flaps 30 and autopilot engaged, flying an ICE RNAV approach. And of course, those of you that fly the 777 with the RNP option, you know the little ANP bars, deviation indicators that show how well you're doing against the required navigation performance. And as we're lined up straight and we're looking out the windows trying to find the runway, those bars get closer and closer, and then they turn amber, and then they come completely together. And the airplane doesn't know what else to do, and it just starts turning. And now I'm turning off final. Well, just then, dipped below the clouds, runway in sight, autopilot off, corrected and brought the 200 passengers safely into landing. Since then, as a Boeing test pilot, we take airplanes to air shows, and of course we encounter the same jamming and spoofing that you do at all these locations that never fail to get jamming over the Sinai Peninsula. And of course, we are actively engaged with your operators and airlines to try to provide information and to explain how best we understand our airplanes and systems are responding to the jamming and spoofing. So having encountered personally the jamming and spoofing, I will say, though, I'm not the expert. And so I reached out to the experts in the field within Boeing to describe what we're doing, the equipment on board the airplane and how it's affected, and what the next steps are. So Nancy, if you could go to the next slide. I'm sure most of you, many of you have seen some or all of these. This actually comes from the EASA Safety Information Bulletin, great resource. Of course, the navigation position is primarily what you think of when the GPS is interfered with. But of course, and of course that might be the ground speed and true air speed, but date and time shift. I don't know if you've actually seen that on your aircraft, but that is a very notable, pronounced effect. Sometimes we joke that maybe you'll get shorted on pay because the clock runs backwards. So we hope that's not happening at your airlines. But I don't mean to make light of the situation, but sometimes it just seems so overwhelming. We have to find a little spot of humor. Of course, the spurious EGPWS alerts, and the alarming thing with that is at some airlines, for example, one of our domestic US carriers flying to Tel Aviv, they procedurally deselect EGPWS, and which means they're deselecting an important safety feature of the airplane. Of course, the deviations in position, loss of ADS-B, we're getting recent information now as well, with EASA coming out with another safety information, a revision to their safety information bulletin that maybe even TCAS might be affected. Our first look at it from Boeing suggests that the TCAS isn't directly affected by GPS outage, but still it's integrated with ADS-B and more to come on that. HUD guidance, autopilot flight director, your approach capability, even though you may be jammed and spoofed earlier in the flight, hours later, when it's time to do an auto land approach, you may be missing that capability because faults get latched. The weather radar system functions and features of that, CPDLC and SATCOM. So I expect, Nancy, we can go to the next one. Many of you have seen these. So I do want to speak to the hybrid GPS inertial system on our 787 platform. And I'll just give a little example of how that particular navigation platform handles jamming and spoofing differently. Of course, jamming is, imagine it like just broadband noise, no specific erroneous signal, just complete blanking. And spoofing, of course, is a component of the signal misdirected, whether your aircraft interprets it as a valid position, but it's in the wrong place. And so it's a much more hazardous proposition because the system can't always tell that it's being affected. So back to jamming on a hybrid inertial system, that hybrid inertial can coast through the jamming. It's got enough of the IRS position and otherwise to make it through, and you can still meet required navigation performance. And its actual performance, it does slowly degrade without GPS. It's kind of like back in the days of oceanic flight when all we had was inertial, and if you couldn't give it an update every 3 hours or so, you could slowly degrade up to 20 miles. Spoofing, on the other hand, the systems may not recognize it as internally recognize that there is a problem. So your flight management system might not switch to radio navigation. Now, your actual navigation performance should be accurate and would show degradation, but other systems can be degraded, remain degraded post-flight, as we saw in the previous slide. The GPS data, comm, and surveillance functions, so after you fly through the region of of jamming will usually recover. Some systems remain but spoofed, but others might recover. Nancy, let's go to the next slide. General mitigations, of course, you can, the pilot can select a different position update mode, such as DME, if you're over land where DME are available. In the Boeing world, that's through your FCOM supplementary procedures and flight management navigation. Of course, you can always tune up your VOR or NDB navigates again if you're over land. For the operator, we're recommending developing pilot recurrent training scenarios, and I'll be curious to hear afterwards, Stuart and Mike, if some of your represented airlines do have training scenarios regarding GPS. Of course, this your operators need to run their risk management process, their SMS, to assess these operational risks, and don't forget your MEL. Make sure that backup systems to GNSS are operative, especially if you know the route is going to be over these affected areas. And the next slide. Now, as far as working with the Boeing fleet, and Ian will talk about the Airbus fleet, we have a flight operations technical bulletin available for each model, and it gives very specific information on the actual effects on that particular model. These threats are evolving, and so we're able to cycle those flight ops technical bulletins current to often to stay up with the latest findings. If you're encountering trouble that's not already covered in the flight ops tech bulletin, you can post your request, or your fleet manager, your Boeing fleet manager at your airline can post a request at the Boeing Fleet Idea Exchange page on their maintenance toolbox. We do have monthly calls, operator calls for updates. And again, if your Boeing fleet manager or your airline is not attending those monthly calls, you need to get on them. And of course, reaching out as you're doing now with this pilot group for more information. Now, Boeing and Airbus, we do have a slight difference here, and Airbus does publish a procedure, and Boeing publishes the flight ops tech bulletins. We're still assessing what's most helpful to the community. I'll start though with the request for no technical objection. So if an airline wants to create a procedure that's not already covered by an OEM, they can create the procedure, and then they'll submit the procedure to Boeing or Airbus and ask, can we get even though we know you can't approve this procedure, can you at least say you have no technical objections? So that's an NTO. And working with Boeing, we haven't yet produced no technical objections because we don't have an equivalent procedure to reference. And also it gets to the sticky issue of circuit breaker resets. Whenever it comes down to what would a procedure look like, it comes down to, would we allow a pull and reset of the circuit breaker? We've had that is a very challenging topic to deal with regulatory guidance and understanding the risks and mitigations. First of all, in general, for pulling and resetting a circuit breaker in flight, and then specific for doing it in this case. So all I can say for now is we are we want to make sure that we produce the best information that we can and support you, the operators. And if that eventually means getting a procedure published, then we will go that route. In the meantime, we're still working through what regulatory guidance would look like with pulling and resetting a breaker, and whether that's the right thing to do on the Boeing platform. I'll talk about some more mitigations that we're working on in just a moment that might alleviate some of these concerns as well. And of course, if you're observing symptoms that aren't in the flight ops tech bulletin, submit a message to Boeing. You can reference, I've noted there, put GNSS RFI in the message, and we have a fleet team digest that details information to submit. And again, Boeing is every month and directly working with operators. So I trust someone at your airline is attending and directly involved with Boeing, working with Boeing. Okay, the next slide, Nancy. Here's our three-pronged strategy or arrow direction that we're going. First, to contain, improve, and then go for resilient navigation. So the contain side would be first just define and document when RFI is occurring and communicate recommendations. And that's where we're at right now. Improve would be the GPS resilience improvement. So actually making changes to hardware and software on the aircraft to make the equipment more resilient. And I'll share a little bit about that in a moment for very targeted airplane system improvements. And some of these might relieve the need to pull and reset a breaker soon. And then resilient would be making an airplane where a short-term loss of GPS just has no operational impact, and making airplane systems that are resilient to the GPS. And we have a little short video on the research side of our company that's working on that. It's been fun in the position that I have as the chief pilot for product development. And in addition to our large aircraft platforms and eco demonstrators, sustainable fuel, new materials, we also have a little Cessna Caravan, a small turboprop high wing strut race wing, and we hang sensors off the struts, and we try out antennas and receivers in the aircraft. And every year we fly it in a GPS spoofed environment produced by the Armed Services here in the US to try to, again, develop resilient components. Let's go to the next slide, though. I have a whole video on that one. So on the contained portion, this is where we're at right now, what I shared a little bit with you on the Flight Ops Technical Bulletin. We are developing some detection and reporting through ACARS. And I know Cargolux has had a little bit of success with that already, where the airplane reports via ACARS after flight, and dispatch can see that the timestamp on that ACARS report is not matching reality. And they can therefore recognize that aircraft encountered spoofing, actually that would be spoofing for the timestamp. And now moving that back in time to actually be able to send a message to the aircraft where the ops center could tell the aircraft, we believe you are being spoofed right now. That could be a benefit. So that's part of the detecting and alerting. And so we're making some progress on the ACARS side. Of course, we're working with the Flight Ops Technical Bulletins, updating our maintenance documents. And of course, every time we get those encounters for each model, we do a root cause analysis. And that's what's leading to these engineering changes in the next phase. And of course, our monthly all operator calls to get the latest information out and receive information in from you. And the next slide, Nancy, goes to our improve stage. We're trying to make the system more robust and able to self-clear. I've got 5 example systems where we are actively making updates, and these are on scheduled improvement plans for the multi-mode receivers, the 787 ERS, and its integrated surveillance system, working with our supplier of the enhanced ground prox warning system, and not just looking at the new airplanes, but taking care of our fleet, the 777 airplane information management system. The Boeing team said, no, I can't actually publish the dates on when those will be there. So I've got a banner underneath that just says stay in contact with our Boeing fleet team meetings for status updates. But I can tell you that those 5 updates are not years off. They are actively being worked now, and it's just a matter of getting the normal engineering design and quality production process through to get these out to the fleet. So stand by for more and stay in contact with the Boeing fleet team meetings. And then the next stage in the resilient phase, so to build interference resistant avionics and antenna, we are actively testing potential mitigations. We are taking that, we have this research aircraft taking those components into live spoofing and jamming conditions on multiple, we'll say multiple spectra or shapes of the jamming and spoofing in time and position and altitude and speed. and every year for the past 3 years, and learning more and more. We are coming closer to solutions, and those are being fed into the design changes as well. We do have a little video I'd like to share with you, and so Nancy, if you could cue that up.
Santa Fe area traffic, Boeing Bravo X-rays departing.
Robust SatNav is all about trying to increase the resilience of satellite navigation.
Compared to the older methods of navigation, GPS is in many ways the standard now.
And there's been this reliance built on a robust GPS system.
Now we're starting to see more and more instances of RF interference into GPS, and in some areas of the world it's actually chronic to the point where it's a daily occurrence to see jamming and spoofing of GNSS.
It's imperative that we make it solid so that it can stand up against current threats, stand up against future threats.
In order to support this, we've been on a campaign for years now to participate at NavFest.
NavFest is a DoD-sanctioned event that focuses on GPS denial and GPS spoofing events over the White Sands Missile Range near Holloman, New Mexico. All our testing is at night. The DoD has decided that the best time to spoof GPS is when there's the least volume of traffic.
The Air Force has all sorts of jamming devices across the missile range that are very, very high powered. Some of the scenarios are spoofing scenarios where they will change the GPS position of the airplane being reported to different airspeeds or different altitudes than the ones we're actually flying. And then there's a whole variety of different jamming signals being used as well. Santa Fe is in a unique position because it's on the north side of some mountains that are able to block that jamming power initially when we start up our systems on the ground. And then when we're up in the air and can transit onto range, it gives us kind of a wide range of data quality from no jamming noise present all the way to the really high-powered jamming noise that we get on White Sands Missile Range.
So as we're flying from Santa Fe, New Mexico, we're navigating via old-school VORs in anticipation of losing a GPS signal. You can start to see the GPS signal degrade, and so you know it's going to happen, and then it just drops out completely.
So that testing over the course of the last few years has helped us develop new technology.
We're looking at new algorithms and techniques that could be deployed within receivers to make them more robust.
And maintain safety, really. This is a safety project at the end of the day.
It's what this technology does. It makes aviation safer for everyone in the skies.
Right, Rebel 1, stay with me. The wind is 280 at 6, runway 3, clear to land. Clear to land, runway 3, Rebel 1, thanks.
Well, thank you everybody for your time and attention, and I'll yield back to Stuart, and so we can continue with more information from our other OEM.
Well, thank you very much, Kirk and Nancy. That was illuminating. Excellent presentation. We've got a whole load of questions coming in, which I know that Mike and the rest of the team are in the background. They're trying to corral those into similar topic groups. Just an appeal, if you've got a question, by all means use the chat for chat and discussion, but if you've got a question, a direct question you want to ask, please post it in the Q&A, because we can keep close tabs on those and actually post direct answers into those as well if they warrant one. So thanks very much once again. I'll hand over to Ian and Laura for the Airbus presentation.
Okay, so there's 5 areas that we're going to go through: the overall aircraft architecture, the main effects involved, short-term actions, mid and long-term, and then conclusions. Is that good? Got sound?
We have sound, we have vision.
Brilliant. So let's start again. Let's have a quick look at the overall architecture review. And as I said, I was talking to myself because I muted it. It's a bit like when you're playing with different Visio conferencing systems, a bit like changing aircraft. You get familiarized with one type and then you go to another one and it changes. So my apologies for that one. I was not found up on this one. So when we talk about overall aircraft architecture review, what are we talking about? In terms of GNSS navigation on the Airbus aircraft, you can have 2 different types. You've got the hybrid system, which is on the majority of our aircraft, or you've got the autonomous system, which is on the older aircraft, the A300, 600, A310, some very few A320s, and in the A220. The difference between that is the hybrid system is an interface between GNSS and IRS, whilst the autonomous uses the GNSS signal for the navigation. Then what we start to look at what are the end users of the system. And I'm going to take as an example the GNSS hybrid navigation architecture. The reason for this is it's important as an end user to understand where the GPS signal comes in, who uses the GPS signal, or what uses the GPS signal, and therefore we can understand some of the impacts. So on a hybrid system, the GPS signal will be fed into the inertial system. And if we look at the end users, there are three different end users. You've got navigation, surveillance, and time. So position, navigation, and time. So in terms of the aircraft navigation system, the inertial reference system on a hybrid system takes an IRS position and a GP-IRS hybrid position to use for the navigation system. Then we talk about surveillance. Surveillance are the things you see in the flight deck. It's the TORS predictive modes. It's the ADS-B. And we see that quite effectively when we either have the TORS alerts, the GPWS alerts at 30,000 feet, or we've got, if you follow on Flight Radar 24, the ADS-B signal, where it shows an aircraft, for example, doing circuits over the north of Iraq. When we look at the FMS signal, it's traveling straight across Saudi Arabia. That's when we see the GNSS signal being used by surveillance. The third user is the time reference. The time reference is used by things such as CPDLC, also used for the ADS-C and for FMS predictions. So as I come back, these are being the three main users: navigation, surveillance, and time. So what's the main effects observed? And I think if we talk about the main effects observed, this is the key point on you as the end user and what we're seeing. The first one is, what are the main effects on surveillance? If we consider the effects due to erroneous GNSS jamming and interference, the first one is the undue predictive TORS alerts. As I said, this is the one we see quite regularly, the GPWS alerts at 30,000 feet, 35,000 feet as you're traveling across the desert and places else like that. The other one we see is the terrain map shift displayed on the ND. And what we are getting the reports here is people say, the aircraft is out of position. But what it actually is the terrain database, or the terrain map, is displayed in the ND. You have a GNSS interference, and that moves. So we've had cases where the aircraft have been flying over mountains when there are no mountains in the area. We've developed some pilot actions for that, and we'll come into that later. The first of all, in our flight operations manual, we've got a chapter on GPS GNSS supplementary procedures. And also it comes down to the airline policy on what your policy within your particular operator is to do. The second one is the loss of surveillance functions above 5,000 feet. And this could actually end up leading to different error messages related to different systems. And these are the systems that use the GNSS signal. It could be a GPWS fault, it could be a TCAS fault, or on some aircraft we're also seeing the predictive wind shear fault. Again, what we recommend to do and to follow up is to do the ECAM actions. Each one of these faults will come up with an ECAM procedure, and the key is to follow what the ECAM procedure does and don't come up with your own procedures. And the other one is in the FCOM, we've got the GPS and GNSS supplementary positions. The third one, as we came up earlier, is transmission of erroneous positions. This is the information being transmitted by the aircraft, and it can be seen quite visually if we look at things like Flight Radar 24. If we come down to what the key messages is, in our ECAM or in the FCOM, we have got supplementary procedures, or we've got the ECAM procedures on what to follow. The key one is to follow the provided operational procedures. And we've put here a link to a reference, and this reference is probably the red line that goes all the way through, the in-service information letter 3436-00049. That is where we add and put the information in that may be of reference for your aircraft. The second one is, what do we do with cockpit effects on navigation? The first one is linked to the GPS position and altitude not consistent versus the aircraft position. And one of the big ones we see here is the altitude. For example, we could end up with an aircraft where we know is at cruise level, all of a sudden getting an altitude that's registering at 0, or even in one case, I remember seeing -7 feet actually being registered in the GPS position or GPS altitude. You may also get ECAM alerts which highlight a disagreement between the FM and GPS position. The action in that case is to follow what is written in the recommended procedures and provide the information for that. One notification that we're seeing quite often now is erroneous erroneous wind speed and direction. And what we see on that one is the wind speed coming from an angle, maybe 270 knots or similar, where you can quite obviously see that is a incorrect wind speed, or it could be the wind speed direction, the wind direction. On the 220, what we do see as well is the FMS map shift, and the recommendation on that one is to follow the flight operations procedure. Again, the thin red the message that we follow at the bottom is to follow the operational procedures, whether it's an ECAM procedure, an FCOM procedure, or even a QRH procedure. And for more reference and more information, to refer to the in-service information letter. The final one is the impact on GNSS time and date, which Kirk referred to earlier. And what we are seeing, this one could be an erroneous aircraft time and or date. It could be an erroneous time in the FMS prediction, or even in some aircraft, in some cases, the loss of CPDLC functions or the ADSC applications. The pilot action in these cases is again to follow what we've written in the FCOM relating to the GNSS supplementary procedures. The key point on this is most effects are temporary. We underline most effects because there are some persistent effects that have been seen occurring, and most of the effects are cleared after leaving the affected area. So now you've understood what we've seen, the usage of the functionality within the aircraft, and now we're just going to quickly go through for the pilots the operational review, what we recommend pilots to do and the flight crews to do, and how we've listened to a number of the comments and we've actually modified our documentation. The first one is having the FCOM enhancements against GNS interference. Since GNS interference has come on the market or become aware about it, we've updated the flight operational documentation. First of all is we've got a cockpit effects table. That's a reference table to tell what is happening, and as and when we get informed of new effects, this will be updated once we've assessed and understood what is happening. We've also included in the FCOM the effects of the erroneous GNSS signal, and in addition, we've provided some information on the persistent effects. These are effects that do not clear once you're outside the zone. Then what do we recommend? If we take a flight and we know potentially we're going to enter GNS interference, let's take this flight through different stages. The first one on the flight preparation. There are zones in the world that we're relatively aware about where there will be GNS interference. So the first thing as part of the threat and error management is to anticipate the GNSS interference. Are we going to fly through it? At what point? And have we seen this before? The second one is preliminary cockpit preparation. The first step is to consider the IRS full alignment, making sure that the IRS is functional and it's fully aligned. Now, what we've also identified is some airports, particularly over the Eastern Mediterranean, may be affected by spoofing. And what we've developed is a procedure for the A320, which enables us to align the aircraft on ground. And this is at the moment available for the A320. For the other aircraft, it is something we are looking into. Then during the flight, before the interference area, one of the things we say is protect the aircraft time to switch to the internal time reference. And the other one is to consider GPS deselection, again, depending on the aircraft configuration. And this is information that we now put in the FCOM, and we've updated the FCOM accordingly. Then, once we're inside the interference area, take consideration for undue TORS alerts. Be aware that an undue TORS alert may occur. And if there is an ECAM alert, then follow the procedure. What we don't want to be seeing is application of procedures that are not in line with what we require. And finally, once you leave the interference areas, restore the systems to nominal. For example, if you deselected the GPS, reselect the GPS. And this is one of the parts of the threat and error management, is being prepared and knowing what to do when you leave outside the area. The second one is to be able to follow what we recommend for persistent effects. And again, this depends on the aircraft configuration and the type of aircraft you're flying. And again, the information on the persistent effects is included now in the FCOM. So there we talked about the short term, the operational procedures. Now let's a little bit more into the mid and long term. This is about, as Kirk went on earlier, building the aircraft system and resilience. So if we talk about short and mid term, what we're looking at here is developing some avionics enhancements. On the A350, we're going to improve the ADRU to address the latch rejection of the GNSS, and the A350 operators amongst you may have been seeing that. On the 380, we're looking at improving the MMR to enable a reset in the flight deck to address the MMR persistent effects that we're doing. And then on the 350 and 380, we're looking at improving the resilience towards undue TORS alerts by looking and improving the information on the geometric values. These are feasibility studies ongoing, and hopefully you can understand that we are aware of the systems and the issues. Now it's a matter about understanding it, correcting it, testing it, and then getting it into service. And these things, unfortunately, don't happen overnight. So I'm going to sum up very quickly on what the conclusions are. First of all, if we take the aircraft systems, when we know and we're identifying a corrective standard, the corrective standard is identified, it's ongoing, we're developing it. What we do understand is during the time, we're getting more and more reports from different misbehaviors. And these misbehaviors are under investigation, the aim being to understand and develop mitigation actions that come through. And the final point is to try and look at developing further improvements to GNS interference and to improve GNS interference awareness within the systems on the aircraft. So that's one brick of where we're going, working on the aircraft systems. The second brick, which is the one that we can do immediately, is about operational procedures. We've made operational procedures available in the FCOM. If and when new cockpit effects are confirmed, and the key word there is confirmed and understood, then we develop dedicated communications and, if necessary, update the flight crew operating manual. Similar to what Kirk said, we have regular webinars with the operators. Keep it aware and keep communicating. And as and when we see an update, we'll update it and push it out to the operators. But be aware of the regular webinars. We had one in June, and we've got another one coming up at the back end of the year. The important one is feedback. We need to monitor and understand what you're seeing. If you see GNS interference, if you see something that isn't quite normal, then tell us about it. And hopefully with as much data as possible so that we can understand technically what is happening. And then we can evolve the systems or indeed evolve the procedures to help you. The key of understanding what the threat is and key of understanding where we're going is sharing the available information. So please, if you see something, report it, share it, and provide us the flight data so that we can continue to improve our system. And finally, as I said earlier, it's an issue that is affecting the ecosystem. It needs to be addressed at the industry-wide level, and we are actively involved in all the relevant forums, evolution of regulations, standards for design of avionics, and also recommended practices. It's about working together as an industry against this threat that we are seeing. So hopefully this can give you an idea on where we're going relating to how we're going to contain, improve, and improve resilience of the aircraft against the GNS interference. It is a threat that is active and evolving, and it's something we need to be alert to over time. So thank you for that.
Oh, that's excellent. Thank you very much. Thanks to all participants there for a couple of really great presentations that dug pretty deep. Apologies, of course, to anyone who's not a Boeing or an Airbus flyer, but I think the overview is very useful and a lot of that information highly relevant to whichever sorts of aircraft that you fly in your day job. Mike and the rest of the team have been beavering away behind the scenes, trying to corral the questioning. I'll try to pick up on everything. A few questions that come up on a sort of repeat occurrence, so we try to coalesce them. Of course, feel free to post further questions. Use the Q&A if you would, so that we can capture those. Lots of good comment as well in the chat box. And a note to Mark Z of Ops Group. Thanks. He's posted up the information about the Ops Group spoofing workshop as well, which is going on. You'll find that in the chat box, and it's well worth everyone getting involved and making contact there. So thanks to, I'm hoping that Nancy, Kirk, Laura, Ian can hear this, and it's everyone. Mike, are you going to join on screen as well? And we can do we can run through a few of these questions. Some of them are general, some of them are aircraft type specific. Just waiting to see Ian on screen. At the moment, I've got Mike, Nancy's placeholder, and there you go. Fantastic. Right, everyone hear me okay?
Yes.
Brilliant stuff. Okay, so some of the questions that have come up. First, quite a general one. Who is carrying out the spoofing?
You know, there was at John F. Kennedy Airport, JFK Airport in New York, early days of GPS, they noted jamming taking place right on final. And it came to the attention of FBI, and they were tracking down who are these actors. Well, it turns out there's an interstate that goes right past the airport threshold, and the truck drivers, fed up with being tracked, had their own homegrown or bought on Amazon GPS jammers, and they would pull over at the rest stop, and their jammer would still be on, and it's right underneath the final. So, there are some cases where it's not necessarily malicious actors, but certainly we believe the predominance are the malicious actors that are intentionally or self-defense mitigations for nation states.
Do we think any of this is being deliberately targeted at commercial aviation, or are we just a collateral victim, if you like?
I've got a slide that I was just trying to find. I didn't put it in this presentation, but one of the things is there are three types of jamming or spoofing. The first one is let's call it maintenance and repeaters. So sometimes you need to do maintenance on the aircraft. You put the aircraft in the hangar. You need to use a GNSS repeater. If the hangar's not hermetic, you could have a leakage, and that could impact aircraft in the vicinity of that one. Of course, it's just purely collateral and accidental. The second one that we're seeing is sort of defense aids. This is the one we're seeing most of the time, which is the collateral spoofing, in that a state or an organization will put up a GNSS radio to GNS interference to put a protective bubble around that zone, and you fly into that. So again, the aircraft is being the collateral from that situation. And then the third one, which is the one that I think everybody most is worried about, is what we call targeted spoofing or targeted jamming. And that is where a single aircraft is targeted for that. We have never seen a case of targeted spoofing. Everything we've seen is collateral, usually I'd say state-based, but there's some other interesting ones. Kirk touched on the truck driver. We've also had a lot of cases at one point going to Mexico City. And then you suddenly realize the aircraft was flying straight over a prison, and they were using GNSS jammers in order to prevent sort of the drones being used to fly things in, illicit substances into the prison. So you can see that there's a wide range and wide variety of it. But the main one we're seeing at the moment, Eastern Mediterranean, Northern Baltics, is related to, I'd say, state protective actions.
Understood. Thanks very much. So a question from active pilots. Different procedures have been instigated regarding EGPWS inhibition, and there's always a concern when we do this that might lead to downstream effects, such as perhaps ignoring genuine warnings, the kind of cry wolf scenario. So what can we do to mitigate?
Right, and And I'll note the term eGPWS and GPWS TAWS, they've evolved over time, and I'll readily confess that the Boeing checklists don't always keep up. For example, an eGPWS is generally the term we use for the predictive ground prox. GPWS is historically the term for the radial altimeter pinging underneath you. That radial altimeter pinging underneath you, looking for a slope profile of the terrain, wouldn't be affected. So those warnings initiated from that radial altimeter are still valid. But they end up falling sometimes under the same term in the mind of, oh, it's all TAWS and eGPWS. So yeah, this is obviously needs to be addressed, as Ian pointed out, that eGPWS, the predictive, is getting direct, GPS source information, and that component can give an incorrect warning.
So it sounds like a training publicity issue, just to reinforce that message that the reactive alerts are always valid and react in the way that you've been trained to react.
Yeah, it's hard for the pilot in the moment, though, necessarily to distinguish, is that coming from the radio altitude source, or is that coming from predictive? So fully appreciate the problem that we're in.
Another query in regards of the latching.
Sorry, Stuart.
Sorry, carry on.
Point from that one, because I think it's both manufacturers are roughly down the same line, but I think Laura's got something to say.
Oh yeah, please do jump in.
In our perspective, initially we were more with the idea to brief the pilots to be aware that they could have some alerts in flight and maybe have the possibility to disregard alerts. However, we are getting really alert, and mainly a lot of concern from operators, for example, about the unused alerts at cruise level. So we have introduced in the procedures the possibility to inhibit the terrain functions and cruise level above MSA. Concerning the other flight phases is a little bit more complicated, because it is true that the reactive modes will still be valid, of course, even at cruise level. However, we have some behaviors, for instance, with certain TOWS systems, that actually when the predictive modes are active, the mode 2 reactive modes are inhibited. When we inhibit the predictive mode, we reactivate the mode 2 alerts. And actually, the mode 2 alerts, for some equipments, they can create some nuisance alerts at some locations where with clips, etc., because there is a sudden change in radio altitude. So we give this information to airlines in order for the airline to analyze, for example, the different approaches in the routes, to make sure that in the flight path you will not have this kind of sudden radio altitude changes that could create nuisance mode 2 alerts. So it is true, basic modes are still available, but could generate some nuisance depending on the approach. So for the cruise level, we are okay with the inhibition. For other flight paces, this is according to airline policy and the analysis of the network.
Thank you. Thanks for that explanation. We talked about latching and the way that sometimes it seems that certain of these effects remain stuck for the remainder of the flight. And that's caused some problems where, for example, aircraft have been unable to accept subsequent clearances onto maybe the OTS, where they need to be RMP4 and they haven't got sufficient navigational capability, or possibly more seriously, one of our committee members spotted that there are RMP1 airways in the Gulf bordering on no-fly zone airspace. So you've got some really tight margins there in critical bits of airspace. So the latching effect, how close are we to resolving that such that we can avoid for the remainder of a flight, suffering from effects which occurred some hours before.
Yeah, those are some of the hardware and software changes that we are doing, and also it can latch and affect your ability for the autopilot to do an auto land, which is disconcerting as well. It's been hours since your jamming episode. You're not thinking of that when you're on final and working through your auto land approach, and yet you now are unable to do an auto land. We've also maybe I'm going backwards here. We've seen spoofing occur to draw aircraft into a nation's airspace for the purpose of then attempting to elicit fines and recompense for operating in the airspace, so that there's levels of maliciousness, I suppose, as well. But yes, latching exists, and most systems recover, but there are specifics that do not.
Any thoughts from our Airbus colleagues?
Yeah, I think the latching one is an interesting one. But if you look at what we've done in terms of the FCOM, we've updated the FCOM to add the information related to persistent effects, which is, I guess, what your terminology latching. Where we're able to do something, we've added a procedure in the FCOM. Sometimes the aircraft architecture is such that we can't do something. And I give an example. If you want to do a reset on a 320, the circuit breakers may be in the flight deck. If you want to do it on a 330, you've got to go down to the avionics bay, which is a no-no in flight. So the only way to modify that is then to look at the end users and the equipment and see what we can do to improve the equipment. So we have to take it in the two-pronged approach. First one is seeing what we can do in terms of an operational procedure, and where possible, we'll put it in the system. Second one is saying, okay, if that's not possible, we'll need to go down the equipment improvement side, which will take longer to do. And that's the status on that one.
Well, sort of following on from that, then a couple of other questions and queries raised that quite a few company procedures require trip and reset of systems, MMRs and others. And sometimes maintenance support isn't always available. So pilots are being required to undertake what you would say were sort of critical maintenance inputs, which they wouldn't normally expect to do. So there's an ancillary risk there of people undertaking actions on the aircraft perhaps that they wouldn't normally do, and therefore causing further other issues outside of the GPS, GNSS spoofing jamming area, maybe because they're just not familiar with having to do with these procedures. And it was mentioned the other day, instead of complex CB tripping and resetting procedure, is it possible that you could imagine a kind of a single switch based system or design which might allow pilots to disconnect the aircraft from GNSS inputs, maybe with a single guarded switch on the flight deck or something like that?
So this could be part of the ideas that are being considered, but however, the latch of the MMRs would still be there. I mean, as soon as you have the signal at the input of the MMR, even if you don't use the MMR input, the latch is there. There are different possibilities we could think about regarding to improve the resilience of the systems. But anyhow, this is not something that is available today. Today, we only can work in avionics improvements for the time being. Of course, we think about more mid-long-term actions and the procedures. And for example, for the latch in flight, for the MMR, because we have different latches, for the MMR one, we allow now this in-flight reset of the MMR only for when the aircraft that has the reset in the cockpit. Yes, that there is always this risk of, but we have evaluated at least that there are not side consequences of these resets before introducing it in the operational documentation.
Thank you.
Right, and we, I'll confess, we're maybe a little jealous of being able to have circuit breakers to reset in a procedure there. We are exploring the concept of resetting in flight. Significant regulatory issues with that. We also have some unfortunate history of aircraft accidents where pilots pulled a breaker for the wrong system or with the wrong idea of what was really going on. So I really fully appreciate the regulatory concern and the safety concern. We share that as well. So to this point, we are instead trying to get the MMR and the system designs to self reset, for better lack of a term. I love the idea of maybe having a pilot operator switch, but again, anything that we would add to the airplane mechanical, we'd have to look at the safety effects that could introduce a single point of failure if that switch fails and now you've inappropriately disconnected proper GPS. So those are the types of things that OEMs have to think about in introducing any new component to the airplane or capability to the airplane. And we share your frustration with and speaking to operators with needing to have some control over the situation. And gosh, if we could just pull some breakers, wouldn't that help? We're struggling through it. So, and I applaud and appreciate our Airbus colleagues that have been able to find a way to be able to do that on some of the selected systems.
You've sort of anticipated some of the questions posted as well there, Kirk. There's obviously a couple of guys on who are Boeing pilots, and one of the questions was, why doesn't Boeing develop an in-flight reset procedure? So we've had a great answer to that. And the other question is, who has access to the Boeing FOTBs?
Right, so those ordinarily would be published within your airline operations center and accessible on your wherever you get your FCOM information. You would find your flight ops tech bulletins. So if I may ask that you inquire of your Boeing fleet chief and make sure that those are properly being distributed and accessible.
Thanks. So it's a note out to all those who've asked that question to go and do something about it. State and military aircraft use anti-jamming. Can we expect it on commercial airliners?
It comes back to the point of car criteria.
Mm-hmm. Right. We, of course, both Boeing and Airbus, we have large defense sectors, and when we talk to our colleagues over there, and they say, "Hey, we've got that solved," we're like, "Can we have it?" and so there's information traffic in arms regulations that prohibit some of that direct application. In fact, the video that I showed, we had to redact quite a bit from that, and I'll just leave it there because we need to be able to develop the technology. And this leads into the other question: if we're making improvements, certainly the malicious actors are seeing this and countering it. So we don't talk a lot intentionally about the actual details of what we're doing to improve the systems or what additional components might be added to the airplane. But we know this will be a never-ending battle to keep protecting our commercial aircraft, knowing that the malicious actors are adaptive and agile.
Thank you. That's anticipated another couple of questions as well in that answer too. That's fantastic. A note here. So there's a PBM mandate by 2030 across the world. How are the plans likely to be affected?
Ian, I don't mean to just hog all the airtime, but if I can, I do have the privilege of sitting as an advisor observer on the flight operations panel at ICAO, and it's well recognized that the deletion of ground-based navigation aids, there was an emphasis to rid the world of VORs and ILSs and DMEs, and that has markedly stopped. Understanding that we rely on those for mitigation to GPS issues and jamming. So performance-based navigation can only work in an environment where we have reliable, available, high-integrity GPS, and that is being recognized at the global level and through ICAO. So yes, it's a valid concern, but from my observation, participating in these groups, that concern is being recognized.
I just see that a note has popped up from Sindre Hilstad, who's a colleague of mine from European Cockpit Association, Norwegian pilot, and I know that he's all over this topic as well, because of the very specific topographical issues that occur around Norway. We talked about this in regard of digital towers and all of those sorts of things, and the necessity to maintain another robust method of navigation. The next question, which is along those lines, are other methods of navigation being considered? Do we need ground-based GNSS type capability going forward? And then just slightly following on from that, instead of considering satellites as individual entities, should we now consider the wider GNSS system to be itself a single point of failure? And that sort of approach as well would work when you're thinking about extreme space weather events that might deny service from the space-based navigation too.
Ian, did you want to jump into that, or I've got a couple?
I'll let you answer that one, because that's it's quite a philosophical question in some ways.
It is, and so I'll just approach it from an airplane manufacturer's perspective. When we talking about the single point of failure, when we run a functional hazard assessment on the airplane, we don't assume like one satellite has failed or another. We just have to assume functionally the GPS is jammed or spoofed, and then look downstream at all of the effects. So from the manufacturer's perspective, we have to ensure the airplane is safe, and that the hazards of whether they're minor, major, hazardous, or catastrophic are appropriately mitigated and brought down to the lowest reasonable level. So yes, I do agree with the person that asked the question about considering the whole system as a single point of failure. Absolutely. And you know, the spoofing really is worse than jamming. Jamming is just loss of. And whenever you do a functional hazard assessment on a system, on an airplane, the loss of a system, it's easily recognizable, easily contained, and you can have redundancy to correct it. But an erroneous system, an autopilot that's still working but turns the wrong way, or flight management, that is much, much worse. Erroneous, or it's like an unenunciated failure. It's very difficult to deal with, and that's what we're dealing with spoofing.
Thank you. So we're getting towards the end. If anyone's got additional questions to ask, I've got a few more thrown up. Please chip in on the Q&A section if you've got anything else as we move towards a conclusion. But so a note here, from March to June this year, 900 flights estimated to have been affected on a daily basis, sometimes up to 1,350. And the thought is, we're thinking really perhaps about our colleagues in ATC here, airborne faults and failures in history generally have been confined to an individual aircraft. So that allows air traffic control to retain sufficient capacity to handle all normal traffic load, whilst giving extra attention to the aircraft that's in difficulty and dealing with them separately. But the problem here is that we've actually got an issue, these big issues, confusing issues occurring to multiple aircraft in the same piece of airspace. So there's a risk of us overloading air traffic control as well as the pilots in that sense. How do we mitigate against that? How do we ensure that air traffic control are able to cope with the overload situation when multiple aircraft are experiencing navigational difficulties?
It's probably compounded as well. I know the use of Squawk 1000 is more prevalent over Europe, and that is complete reliance on ADS-B and GPS positioning. So in a sense, we are setting ourselves up. I don't know, Ian, do you have some insight to answer this one?
Again, I'd say that one is, we're looking at it from an airframer's point of view, and the other side is the the aspect from the ground, and I think it's better to be responding at how does the ground handle that level of loss of GNSS? What are they seeing? How are they managing it? We do know there's certain zones and certain areas of the world where it's happening. How's that being managed and how's it being addressed, I think?
What I can say from our side is that we recommend to, of course, to pilots that are experiencing this kind of effects of jamming or spoofing to contact the ATC, to notify the ATC when this is happening. This may help controllers to better deal with the situation. But there's not much more we can do at our level, at least from the flight operations perspective. Of course, we are in close contact with authorities, for example, with the EASA. We contribute with Eurocontrol also in this kind of discussions, but that's a really general industry question to be answered.
Yeah, you can go to the extreme and exclude the airspace, treat it like a volcanic eruption event, but if there's affecting world commerce and economy and even safety of people needing to move about when they can, and the airplanes are otherwise capable with some unfortunate effects. So yes, that's a very important question. One which arguably I'm not equipped to answer for the industry.
No, as you say, philosophical questions really in many regards. But the important point as well, I think that you touched on there, Laura, was that we need to make sure that whatever happens, whatever we see, we report. And then post-flight, we don't experience reporting fatigue. If this is happening a lot, there's always that possibility, isn't there, that people think, I've written half a dozen reports about this, nothing seems to have happened, so I'm going to stop bothering. And we mustn't do that, because you need all the data that you can possibly get to square this circle away. Mike, online there, what have I missed? Other questions that have come your way?
Nothing, but while you were talking about controllers, we had another question, which was, if I just read verbatim, until now we experienced spoofing over areas covered by radar surveillance where nav and RMP degradation can easily be detected and mitigated by ATC, but a totally different ballgame if in the future it affects areas which are only using ADS-B as ATC surveillance oceanic. Any plans to address these potential serious safety issues? And I was just going to couple another one. There was a question about CPDLC and the messages with inaccurate time stamps on them. And I'm not sure if you guys, if it's in your area of expertise, but I just thought I'd throw that in as well.
Those are very valid threats. Some of the future mitigations are looking to mitigate those threats, and it won't get more specific than that, but it's be a little bit longer term for the specific threat of, let's say, someone sets an oceanic platform, for example, with a spoofing. The airplane still has the hybrid to IRS solution, but it could be eventually drawn off course. And so then you're just left with your contingency fuel and reserve fuel. And you hope that particularly affected airplane doesn't also have an emergency, a separate, different emergency layered on top of that. So yes, absolutely a threat to deal with.
Yeah, on our side, just concerning the CPDLC, for example, we have mitigations. We have the possibility to set the clock to internal mode or manual mode in A350 in order to prevent the erroneous timestamp getting into the system. If the clock was not set to internal before the spoofing and it gets wrong, then the CPDLC capability is lost. This is applicable to all aircraft like the A220, for which we don't have this internal possibility, but it is quite useful for at least to mitigate the CPDLC issue.
A quick question from Alex, who sits on a couple of our different committees. What is being done in sharing information and working with systems such as drones, UAM, and other vehicles that use GNSS extensively they don't fly without GPS in many regards, especially not the big commercial versions of those. So is there work going on behind the scenes in order to try and make those more robust?
I'd say there's a lot of work being done at industry level. So we can only speak for our area of our sphere of influence, which is the civil side, but we are involved also various industry working groups. I don't know, Kirk, whether you're dealing at the same level.
That's right, and other technologies are available for them to draw upon depending on the threat. For example, visual, IR, near IR, far infrared techniques for locating the runway for landing, for example, and navigating in GPS denied environments completely. So there are techniques that can be used in the drone situation.
I've got a question from Mohit, which says, in areas where GNSS RFI is experienced, could we see airport authorities in affected regions withdraw or suspend GPS approaches as a mitigation? Have you been approached at all in that regard?
I wouldn't be able to speak to that, but it seems like a valid safety mitigation.
It comes back down to looking at the aviation ecosystem. There's a lot of actors involved. You've got two around the table here which are relating to the manufacturers, and there are a lot of other ones that will also have a share in the discussion. And if you look at the EASA SIB, there's a lot of recommendations, not just to the manufacturers or the operators, but also ANSPs and airport operators. So they would be the ones that will be able to clearly answer that question.
Many thanks.
Not only to maybe not to limit the possibility of the approaches to PVN, but also to publish NOTAMs, which would be very helpful for operators as well.
Thanks. Well, I mean, there are some other questions which are much more technical and type specific that are in the boxes. Now, I'd suggest those sort of questions need to be directed more appropriately, perhaps to airline technical management and to yourselves through the appropriate reporting processes, rather than perhaps as going on here. We're going a bit higher level here, I think. Mike, is there anything else, any other burning questions that you've spotted in the chat or text that we need to address before we draw it to a close?
No, I don't think so. I did have a sort of personal selfish one though, because I just happened to be reading a document and they were talking about, I started my career with Omega, then it was INS, but there was an article about quantum INS, and where the unit operates close to absolute zero, and it makes very accurate gyros and accelerometers. So again, the whole positioning system of the aircraft can be self-contained once more. And I just wondered if Boeing or Airbus are working on that, or whether there is just a bit more pie in the sky.
I think you read pretty the same article I read. All we can say is we're looking at different technologies to come down to see how we can improve it.
Yes, and we're looking not only at what's on the horizon future tech, but also considering going into the past. Can we rethink all of the radio transmissions that are on the ground, whether it's an AM band radio station or local, and have those chartered, and rethink how we might be able to use those resources as well. So kind of looking forward and backwards to try to mitigate.
Oh, okay, so very interesting. So it sounds like the pilots of the future will be using astral domes, bubble sextants, and Loran and Decker for navigation from now on. Maybe not. Well, I think that's it. I'll draw it to a close. I'm really grateful to Kirk, Nancy, Laura and Ian for giving their time, and to everyone else who's participated and filed all the questions at us. We'll make as much of this available as we possibly can. It'll take a little while, because what we'll do is review the video and then make sure that all the materials that we can possibly put in front of you are out there for general consumption. So with your agreement, Mike, we'll draw it to a close. thumbs up there from the chairman. So all it remains for me to thank Ian and Kirk, Nancy, Laura, for a compelling discussion. Insights have been invaluable. We appreciate your engagement and communicating with us. When you're out there flying, make sure you submit your reports and fly safely. Thanks for attending, and we'll see you soon.
Thank you.